Swayam Prabha. Digital India. Educated India.
Very warm welcome to my friends for the TQM1 course. This is Total Quality Management. I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, we were discussing the house of quality and the different attributes and the so called variables based on which one can understand the quality functions. So, in continuation with that, we will discuss in the 14th lecture, which is as of today. So, we should basically identify the design attributes. So, these are the characteristics based on which you will try to find out what are the important points for which design specifications are important and how such specifications can be utilized to understand the specific quality issues which are very important inherent in the design process or the manufacturing process. So, design attributes are expressed in the language of the designer or the engineer who is working. So, it can be either related to the strength of materials, it may be related to the length of the tie rod, it may be related to the so called viscosity of a fluid, whatever you are manufacturing, and or it may be, say for example, related to the surface finish of a very sophisticated material which you want to use for telescopes and all these things. So, it depends on the language of the designer or the engineer, which is technical in nature and represents the technical characteristics. So, as I mentioned, the viscosity, the length, the weight, the height, the humidity. So, all these things would have basically some measure in the engineering framework of discussion. So, these characteristics are attributes that must be deployed throughout the design, manufacturing and the service process. So, if I say that, say for example, the product has a tensile strength, whatever the specification is, that should basically convey the same set of meaning from the designer perspective, from manufacturer perspective, as well as, say for example, the customer who is trying to utilize that machine or a crane or a material, whatever it is. These must be measurable, that they must be some unit of measure, as I said, temperature in Celsius or centigrade or Kelvin, weight in kilograms, tons, quintals, length in inches, nanometers or say for micrometers, in kilometers or in inches, feet, whatever it is. Weight can mean pound, kgs, grams, milligrams, as it may be. Since the output will be controlled and compared to the objective targets based on which you are trying to find out. So, if say for example, I want to find out how good the coolant is which is being used in a very sophisticated CNC machine. So, obviously, the viscosity is important, the specific gravity is important, what is basically the rate of flow at which you will basically pour in that fluid onto the cutting tool is important. If you are fitting a tie rod, if you are fitting a certain specification material in a machine, in a car engine or in a scooter engine or in, say for example, the aircraft engine. So, those specifications should be mentioned very specifically. The roof of the house of quality shows symbolically the interrelationship between the design attributes and based on which you can make a decision that how good or bad the overall quality specifications are from the designer's perspective. So, you need to basically satisfy their customer needs, that is what the actual the need for the manufacturer is, and the customer need not be the external customer. So, if I am a designer, my customer may be the actual shop floor person who are trying to utilize my drawing. If say for example, I am a manufacturer, my actual customer is the salesperson who is going to sell that product. If the product quality is bad, obviously the customer who is going to sell the product to the outside vendor or outside distributor would face a problem. So, each of the stage which is going to happen next are the customers based on which the design perspective and the overall analysis should be done. So, our main question is, and the elements are of house. So, how do we satisfy the customer needs? What are his or her needs? What are the product requirement? As I said, product requirement can be on different technical terms, which I mentioned just few minutes back. And translation for the action should be very well specified, like if viscosity is important, how do we control the viscosity? If temperature is important, how we control the temperature? If humidity is a problem, how do we control the humidity? Should we have a dust free environment to produce products? Is it too costly? If it is too costly, then how we do basically bring down the overall cost perspective and basically have a positive effect on the quality. So, all the needs and are basically termed and given an weightages, given a rating, given an attribute, they have some qualifications, and we find out that what's and how they are interrelated and what is the level of dependence which is there between the attributes at different levels. Different levels means, say for example, from level 1, which is the designer, to the next level, which is the customer 1, which is basically the shop floor persons. The shop floor person is level 2, based on his or her output, the product goes to the salesperson, in the internal salesperson or the marketing person. Industrial marketing goods are being manufactured and basically being sold in the market. So on and so forth, this linkage continues, and the design perspective, the design idea is basically translated from one level to other, where the second level is the customer, such that all the aspects of quality control are taken into action accordingly. So, we basically have in the design house of quality, the needs depending on what level you are and how you are going to basically meet those needs, such that the customer requirements are satisfied. So, this is what we mean by satisfy the customer needs and the requirements. So, an impact on how each is related to each other. So, obviously, there would be some strong relationship between level 1 and level 2, or level 2 and level 3, and so on and so forth. So, some may be strongly positive, some may be positive, some may be negative, some may be strongly negative. So, when basically we have the correlation information, correlation is basically the level of importance which is there between different levels, and based on which we can judge that how good or bad those design parameters are for the actual product which we are trying to manufacture or design. So, conflict resolution is the main important idea. So, obviously, there may be some issues that as you pay more and more attention on the quality, the cost may increase, or say for example, you are being too finicky about the environment and the humidity, but it would basically have not that appreciable effect on the quality. So, you have to make a decision which is good, which is bad, based on the design parameters for all the levels on which we are trying to pay a huge amount of attention. So, if you basically see this chart, which is the correlation matrix. Now, the word correlation basically comes from statistics, we understand that, and the correlation basically the values which is from -1 to +1 gives you the relationship between two random variables. So, here what we are trying to understand is that what level based on the attributes do we have between different attributes which are at different levels. So, these are as if you see the first column, they are from need 1, need 2, need 3 and goes on depending on how many needs are. And the first row which we have is that how they can be done, how the needs can be met, and they are given, the relationship it is given in the matrix. So, if you see need 1 and how, basically there is a high level of correlation. In some case it may be medium level of correlation, in some case it may be low level of correlation. So, what you are trying to do is that try to understand the level of relationship, level of importance, level of not so importance, or level of negative importance which is there between different levels, different design parameters, different attributes, such that we can understand in the overall scheme that how we can resolve the conflict, such that in the overall set of things we are able to meet the quality in the best possible manner. Now, the word best possible manner does not mean cost, it may basically mean on the customer satisfaction, it may mean on the design parameters, it may mean on the type of quality of materials which you are using. So, this basically conglomeration of different attributes which we want to consider from the total quality management point of view. So, relating customer and design attributes is basically means symbolically we will determine whether there is no relationship, a weak relationship, a moderate relationship or a strong relationship between the customer attributes and each design attribute which is there. So, customer wants, say for example, Young's modulus of, say for example, of a certain value, whether the design parameters, Young's modulus I mean the strength of the material which is being produced on made, or it can basically mean the level of quality of color which is there for the material which is being produced. So, or it may be, say for example, level of decibels of sound level if a product is able to produce. So, it can be either I am manufacturing a boring machine and it will have emit a certain level of decibel of sound. So, whether, and that may be an attribute based on which the customer wants to procure that product. So, the work being done by a boring machine may be very well and good, but if the sound level is very high, then it creates a problem for the customer. Or it may be, say for example, you are fitting a tie rod, I am coming back to the same example, if the length of the tie rod is not matching the actual requirement of the customer, so obviously there is a problem. So, basically we analyze the different design parameters with the customer requirements based on the correlation matrix, which are based on the attributes which may be very strong, moderate and not at all significant. Based on that we divide it. The purpose is to determine whether the final design attributes adequately covers the customer requirements in general. So, obviously there would be many conflicts, but in the overall set of things we see that how the customer requirements can be met to the maximum possible extent. So, obviously there may be cutting down the cost, there may be increase in the cost, there may be something where such sophistication tools to work on those materials may not be required. So, all of these things have to be taken into consideration in order to make the best judgment what is the total requirement between the customer needs and the design parameters or the attributes. Lack of a strong relationship between a customer attribute or any design attribute shows that the attribute is not at all adequate and addressed not properly, or that the final product will have difficulty in meeting the expressed quality needs of the customers. So, some design attributes or parameters are very important, but if the customer satisfaction are not being met, so obviously it will mean that in the long run there would be some clash of the interest between the design parameters or the attributes and the customer requirements, which based on which those design parameters have been really developed and which are the core values for the product which the company is manufacturing, or the design engineer or the manufacturer on the shop floor is in manufacturing. Similarly, if a design attribute does not affect any customer attribute, then it must be redundant and hence the designer may have missed some important customer attribute which is actually not considered, but erroneously some other attribute is being considered which has no consequence on the design aspect with respect to the customer requirements which are there. So, if say for example, the viscosity of a fluid has no consequence on your design parameters, say for example, of a particular machine which uses some coolant to be used, say for example, and if the design parameters of viscosity are not coming into the picture when you are considering the customer requirements, so obviously it means either those are not at all consequential for our decision making, or we may have missed some important attributes from the designer point of view or for the manufacturer point of view, which the customer really had intended to basically consider in our overall design and specification norms when the product was being actually designed or thought about. So, the key elements of the relationship would be basically to untangle the overall relationship which is happening. So, strength between the interrelationship between what's and hows can be done in a very simple way, where you give some points or some level of importance to the attributes. So, they can be done as we see along with the needs and along with the hows. So, the needs again I am mentioning along the first column and the hows are along the topmost row. So, if you basically give some points, so for strong correlationship, say for example 9, medium correlationship 3 and weak being 1. So, this basically gives you a form of transfer functions or the relationship which basically happens between the correlations between the needs and the hows. So, the points which are mentioned there are 9, 3, 1 are not sacrosanct. They can be based on any other perception depending on the level of importance design and the manufacturing parameters or the attributes are, and what the customer thinks are important for him or her. So, basically then you add in the fourth set of points, you add the market evaluation and the key selling points are considered. So, these are done in this way. This step includes identifying important rating for each customer attributes and evaluating existing products and services for each attributes, which are very important for the designing and the manufacturing point of view. Customer important ratings represents the areas of greatest interest which is for them, and the highest expectations as expressed by the customer are to be considered. So, if the customer thinks that the tensile strength is very important, then that becomes one of the most important attributes from the design and the manufacturing point of view. If the customer thinks that weight per unit volume is a very important consequence for him or her, then basically somebody has to consider the density in such a way that that becomes the important parameter to be considered in the design and say for example, in the manufacturing unit. If say for example, the customer thinks that the tolerance level depending on the fluctuation of the temperature is of prime importance for him or her, so those points should be considered by the manufacturer at its or his or her design and manufacturing stage. Competitive evaluation helps, like say for example, if I am a manufacturer, I would basically try to understand the customer's needs and try to judge where my product would be with respect to my rival products. So, whether the design parameters, whether design attributes of my products with respect to my rival products are able to meet the customer requirements to the best possible extent would be considered. So, it means that competitive evaluation helps to highlight the absolute strength and weaknesses in the competing products and helps us to analyze where we stand with respect to the different type of customers, different type of competitive products which are there in the market. This step enables designers to seek opportunities for improvement where things can be done in a much better way, such that the relationship of the importance is highlighted by the type of products at each level we design or manufacture, such that the link of the QFD to customer strategic vision and allows priorities to be set in the design and the manufacturing stage and to the best possible extent. So, in the fifth stage we evaluate design attributes and competitive products and set targets which are to be made in the best possible manner. This is usually accomplished through an in-house testing and then translated into the measurable terms. The evaluations are compared with the competitive evaluation of the products of competitors and customer attributes which have been mentioned by the customer in order to determine inconsistency between the customer's evaluation and the technical evaluations which have been laid down by the customers and how good or bad our products are with respect to the customer requirements. For example, if a competing product is found to be best satisfy a customer's attribute, but the evaluation of the related design attributes indicates otherwise, then either the measures used are faulty or there are some issues about that, or else the product has an image which is different and is affecting the customer's perception based on which his or her customer requirements have been basically designed. So, if say for example, the customer requirement has given us one set of requirement for the products and we are getting some second set of requirements based on what we think are the perception of the customer, then there is obviously a mismatch. So, that has to be made 0 or reduced to the maximum possible extent, theoretically made 0, because it will basically be able to meet the requirements of the customers if the customers actual requirement are translated in the design and the production stage. On the basis of the customer importance of rating and existing product strengths and the weakness, targets and direction for each design and manufacturing units are then taken into consideration by the manufacturing unit in consultation with the design and the shop floor, such that the customer requirements are best met with the designers and the manufacturing attributes. So, once it is done, we need to basically have a consistent comparison. So, this information is again done with respect to the needs in the house. So, what we do is basically you target the values of house and basically note the number of units which are there. So, if the relationship is very strong, obviously the points given accordingly would be coming up very high. So, you need to evaluate each combination of needs and house such that you get the maximum ratings where the designer and the manufacturing attributes should basically match with what the customer requirements are. If they are very negative or they are very low, obviously it means there is some misconception or some misfitting between what the designer and the manufacturing attributes are with respect to the customer requirements. So, the word customer again I am mentioning, it does not mean the external customer, it basically means both the internal and the external customer. That means from set 1 or stage 1, if you pass on the products to stage 2, then stage 2 is the customer for stage 1. So, the best direction has to be taken in which direction your overall requirement should be met. So, basically what you do is that informations are again collated on the needs and the house. Again the needs are along the first column and the house are along the topmost row. So, more or less, whether it is better or worse, basically they are understood in trying to basically understand whether we should increase the design and the level of importance for the manufacturing attributes or basically try to reduce that. As we note that the positive and negative points which we give basically comes out in a much better way such that we are able to collate the overall information to give some points between the needs and the how. So, the best direction is done, and we find out that in which direction the point should move. So, say for example, if you see as in the slide the rightmost column. So, there are points given as 65, 45, 21, 36, 8, 52 and 4. So, this would mean that between the needs and all the house they are, you would basically have a weightages or the level of importance which is given on a scale, whatever the scale is. It can be from 1 to 100, it can be 1 to 200, whatever it is. On a scale it is 65. Based on that we are able to basically judge that whether we should be really concentrate on those attributes based on the needs and the house and try to find out where the dovetailing can be done between the requirements of the design and the manufacturing attributes with respect to the customer requirements. I am using the word requirements of the customer in a very generic sense. The sixth step or stage means select design attributes to be deployed in the remainder of the process. This means identify the design attributes that have a strong relationship with the customer needs. So, what the customer needs you may not be able to understand, but try to basically inculcate that in your design and the manufacturing units, so that basically information comes out to the maximum possible extent. Have a poor, if it attributes that have poor competitive performance or a strong selling point. So, basically they would be done in such a way that those cannot be replicated by your competitors. So, if you have some unique property of your design and manufacturing unit or manufacturing quality is there for the design perspective, also try to basically highlight that such that the customer requirements are met and your competitors are not willing or not in a position to basically replicate that. And they should also be very strong selling points based on the customer requirements from the technical point of view. So, these attributes will need to be deployed or translated into meaningful actual attributes which the customer can understand. So, in the language that each function in the design and the production process, so that the proper actions and controls are taken to ensure that the voice of the customer is maintained and the actual requirement of the customers are met to the maximum possible extent. Obviously, we will all try to meet the customer requirement 100% of the times, all the time, but obviously there would be many mismatch or there may be some mismatch which we will try to minimize to the maximum possible extent. So, those attributes not identified at critical do not need such rigorous analysis. Those which are important, obviously more stress should be made, based on which the customer requirement would be met with from the point of view of the designer and the manufacturing point of view for the attributes. So, key element in the technical informations are, so you want to basically find out the strength. So, what you will do is that you will basically try to find out the overall level of points which you are trying to analyze for the needs and the house. So, what you do is that you try to basically find out the customer importance level, which is CI, and the strength which is already given by you based on what you think as from the designer point of view, from the manufacturer point of view, the level of importance. So, those points either you given a scale of 9, 6, 3, 1 and so on and so forth, or it can be different points based such that gradations are possible, and they give you a very nice feeling that what are the different type of customer requirements and the designer and the manufacturing attributes, which can basically given some points so that they come out in the actual analysis very carefully. So, the total level of technical importance or TI which is there, you will basically find out the sum by multiplying the level of customer importance with the strength, and they sum them up along the column. So, once you find out the column sums, you are able to find out the technical importance of each and every such combination of need and how, such that you can place them in a ranking order, where you can lay more emphasis on the TIs which are of high level of importance from the customer point of view with respect to your design and manufacturing attributes. You also capture the completeness criteria. So, that will give you the level of how complete your overall coverage of the needs and hows are. So, what you will do is that you basically sum up all the points along the rows. So, what you are doing is that you are trying to find out the overall level of from house also, as well as from the point of view of the needs also, such that there is a one-to-one correspondence between those level of points which you have put for the house and needs, such that dichotomy or so called misfitting of all the needs and what you can deliver are minimized to the maximum possible extent. So, again I am repeating, the total customer points are measured along the columns, you sum them up, and also the completeness criteria based on each needs and house are summed up along the row, and you find out the level of points such that a one-to-one correspondence or dovetailing can be done between the customer requirements as well as what you are able to deliver from your point of view. You are the manufacturer, from your actual set of attributes which you think are important. So, using the house of quality, the voice of the customer must be carried throughout the production process, and each point should basically portray that. 3 other houses of quality are used to do this. Together with the first, they carry out the customer voice from its initial expression through the design attributes, through the manufacturing attributes onto the component attributes, and the process operations are considered. So, they are considered in such a way that you go stage by stage from the designer to the conception of the idea to procurement of the material to the manufacturing unit and so on and so forth. So, in Japan, all these 4 sets or house of so called considerations are used. The tendency in the West is to use only the first one or the first 1 and 2 based on the level of importance, but obviously in Japan we know the level of quality consciousness is to such level that they want to basically analyze each and every customer requirement with each and every primary, tertiary and so on and so forth level of importance from the designer and the manufacturing attributes which are there. So, these are, if you see the 4 set of combinations which are there, one is basically the combination of the customer attributes with the design attributes, second is the design attributes with the component attributes, the third is the component attributes to the process attributes, and the fourth one is basically the process operations attributes to the quality control plan. So, when I say the Japanese, they consider that they go one at a time. So, if you see the first, second, third, fourth, at each stage you basically consider both of them, and in the next stage you are considering one of them, such that the characteristics which you are getting in the initial stage are all being brought down in the second stage, such that there is a continuity in your consideration. So, if you consider the design and the customer attributes, the design attributes goes to the second level. If you consider the component attributes and the design attributes, then the component attributes goes to the third level. If I consider the process operations and attributes along with the component attributes, then you see the process operation attributes goes in the fourth level. So, in a very holistic sense, all the combination between the customer needs and the requirements with the design and the production and the procurement of material, everything from the point of view of the attributes and the requirements are met to the maximum possible extent. Obviously, it will mean that you have to very thorough in your overall total quality management process, but it actually gives you some positive benefit in the long run. So, the cascading voice of the customers are design attributes are also called functional requirements, and based on this we do. So, what's and hows are done at each stage. So, the 4 houses of quality, as I mentioned, consider them such that they go from one stage at a time, and you consider all of the feedback considering the primary one, which is stage 1, one of them go into the stage 2. One again between the combination in stage 2, one of them goes to the stage 3 and go so on and so forth. So, if you see, the notes are design attributes are called functional requirements, which I am again repeating. Component attributes are also called part characterization, based on which you find out the characteristics of each and a part of the components. Process operations are called manufacturing attributes of the qualities, and the quality control plans refers to the key process variables, which are very important in trying to basically analyze the design and manufacturing actual set of things which are very important for the customers. So, you go stage 1, stage 2, stage 3, stage 4, and also as I mentioned that, and if you see, say for example, stage 2 and stage 3, the component attributes comes as one of the inputs for the for stage 3, and then process operations goes into stage 4. So, one thing is very important to note, the how and the needs, basically the hows of one state goes and the need for the second stage. So, it proceeds in such a way that the logical sequence of relationship between each and every primary, secondary, tertiary attributes and the characteristics are very well developed between stage 1, stage 2, stage 3, stage 4, considering stage 1, stage 2, stage 3, stage 4 are the house of qualities which we have talked about. With this, I will close this 14th lecture and continue with more discussion in the 15th and so on and so on. Have a nice day. Thank you very much.